Okay, this is hand tools part 2. So, we left off, we did not get to hammers yesterday. So this is what kind of a hammer?
Mallet, a big one.
This is a ball peen hammer. So this, what does this look like? A what?
A ball.
A ball. So this is the peen. Simple as that, right?
Oh, it's real.
All right. So, what is the purpose of a ball peen? Or what other types of hammers are there? So you got a ball peen,
Ball head.
maul.
Ball tip.
Well, we already covered that. And there's one other one that you will never find in my shop. Claw hammer.
Hammer.
Why do we not use claw hammers here?
Because we're not
Unbreakable.
Because that's for carpentry, and we don't do that.
No.
All right,
You don't.
we don't. All right, so we generally use the ball peen hammer for almost everything. So, the difference between this dead blow maul and this ball peen, see how that bounces off? Dead blow. What does it do when it hits?
Not bounce.
Nothing. It's a dead blow. Wow. It has nothing to do with bashing skulls in.
Oh,
Okay. So the ball end is used for tighter areas or when you need to concentrate the force into one small point. Can anybody see a problem with that when we get to hitting small things?
you might break it.
Break the tight and small area.
Hammer, what'd you say?
You might miss.
Well, not totally miss, but something like that. Let's see, let's pick that one. Okay, see this round-headed pan screw up here? So if I use the ball and the peen end, I hit it every time, right?
Yeah.
Because it's what?
Flat.
It's flat. If I use the ball end, what does it do?
Slips.
It falls off, doesn't it? Are you getting the force you need if you're missing it?
No.
No. So, use the right side of the hammer for the right job. All right. Dead blow hammers, mallet hammers are good for larger surface jobs, right? The dead blow is really good if you have a rusty or very stuck bolt and you're trying to get it off. Also, this is a soft face. I don't think we have any other soft face hammers here, and I don't have one in my kit. So, this is a non-marring surface, so if you're hitting something that you don't want to put scratches in, use a soft face. It doesn't have to be a dead blow, but a soft face. So if you're hitting the end of a bolt, sorry. So I just have small things here, but so if you take the nut off of a bolt and you have to hit the end of that bolt, what will happen if you hit it with the peen, ball peen?
It'll damage the threads.
It'll damage the threads. Awesome, thank you. So what's another way of removing this screw if it's stuck?
Flat-heading.
Soft face hammer. Why?
Or some PV blaster.
What's that?
Or some PV blaster.
PB Blaster's awesome. We also use, there's a number of aviation ones. The other way you can, if this is the only hammer you have and you don't want to like go back a mile away and get your hammer, put the nut back on so that you're hitting a larger surface area. No threads are exposed. You're using 4 threads to try to push it back down. Generally, you got a question, it look like, okay.
Yeah, I don't know what you're talking about.
All right, so this screw is stuck in my finger, right?
Alright.
We can either try to remove it with the dead blow. If that doesn't work, Or if this is the only hammer you have in your carry box, put the nut back on the screw or bolt like that so that you have some space. You have to have some gap. And then you hit it this way. Because you've got more surface area, and the nut is going to protect the threads, because a lot of times you have to reuse the hardware. A lot of times you don't, but sometimes you do. That's so if you have to save the bolt. Also, if you're going through a precision hole, there are bolts that are cut down a little bit for a precision hole, which is reamed out. You cannot enlarge that hole, so if you pound on those threads, it's going to peen the threads over the end of the bolt, and you're going to enlarge the hole as it goes through. You understand?
Yeah.
Yeah. Why are we hitting screws?
That's what I
Bolts,
was thinking about.
because you got to get them out.
So only if it was.
So like, you guys didn't take the wing off, did you?
No.
No. Okay, so that was the first hour.
Why do they get to do all the things?
I'm sorry, what?
They get to do all the things.
Do you know why? Because they're here for 2.5 hours, and you're here for 1 hour.
I was thinking,
Yeah, that's
Bus,
so stupid.
bus. I don't make the bus schedule.
They're literally
so.
sacrilegious.
All right.
Burn them at the stake.
So, are there any questions about hammers? Yes.
how do you know you're not gonna wreck the threads if you're hitting a screw? Because don't they make threads in whatever they're going in?
No. A lot of so when we were disassembling the wing spar where the bolt goes through is made out of 5 different layers of skin,
Okay.
and then it goes into a fork fitting. So all those layers go in like this, and it's just a hole. It's not threaded. It's just a hole going through all of it that holds it together.
Okay.
So we had to use a dead blow to get it out, and we had to use a long punch because it was in the middle. It was in that wing root, and you can't get this big hammer in there. So we had to use an extension on that. So that is why so you have to be careful. You can't just smack things around on an airplane.
Cool. Yeah.
Okay, that's kind of the moral of the story. Well, we will get to things the rest of this year where we'll have to be careful. I'll show you things. All right. All right. So those are hammers. Okay.
Wait a minute.
Yes.
So, never mind.
Got it. Does anybody know what this is?
I don't see it.
Hey, level.
It's like
A ruler with a level.
This is a combination square. That name is not on the test. Maybe. I haven't made it up yet, so. All right. Why is it a combination square? Yes, it has a level. Somebody else said
Terrell said. So.
that is a ruler. This is a
Yeah, that's what I said.
It's a combination.
7-inch ruler. Okay. So, but it does a combination of things. Hence the name, combination square. All right. What is this?
That's a square.
That's a square. So what happens if you have something that looks like this?
T-square.
T-square. Yes.
Okay.
Vice grip.
Vice grip.
This is a vice grip.
That's a
Because,
vice grip.
why does it say that? Why do I say that? Because it says
It looks like a vice.
vice grip right
Oh,
here.
because it's not the president.
This is the brand name. This is also the name of the plier. Okay.
So where's the presidential club?
I don't know. So
We don't want
a vice grip. When do you use a vice grip?
On like your
Yes.
use it.
When you gotta hold something on string, guys.
When you gotta hold
Multiple
something.
ways of something you need to hold together.
Okay. Yes. When you hold things together, and not hardware, but like sheets of things. Yes. Anybody else?
Strip screw or something.
Strip screws. That's kind of what we're going to cover with these now. Yes, they hold stuff together. Also, when I'm working by myself, I will use a vice grip on on new hardware, just so that it will stay where I want it to go. So I go to the other side of the piece and work on that side and tighten it up. Kind of understand. Anyways, you guys won't have to do that here because you're not going to work by yourselves. All right. So the vice grip, how to use it. This is the releasing lever. This is the tightening screw. Okay, so we will tighten this down so it touches, and then open it up, give it a quarter turn, and then it won't come apart by itself. Okay, then you have to release it with the lever. Okay, so
Why is that useful?
this is useful because a lot of times you can't, if a bolt is stripped, a nut is stripped where you can't, the socket's not going to take it off anymore, this will get on that and give you the first turn on that, and then sometimes you can put the socket back on it. Okay, and we will, at some point in the year, we'll find some hardware that needs the vice grip, and we'll use it. Right now, there are screws in our 150 that we're repairing around the fuel tank, and the students at some point just drilled the heads off the screws and the tails are still in the fasteners. We will use vice grips to get those off. Right, Jimmy?
Why did they do that?
It just happened. So if a screw's been in something for 50 years, does it want to come out?
Yes, because it's
No.
old. And
No. So Jimmy was working on an antenna. We were removing it, and the screws, the original steel screws, just were stripped
Come on,
out.
Jimmy, what the heck?
So it wasn't his fault. It was a 50-year-old screw.
You should have bought a new plane.
So-
Now look what you've done.
Sure, we all have that kind of money.
So he is trying. I told him to get vice grips and go from the inside and remove the screw part. Okay,
Okay.
we're gonna get back to sheet metal
I agree.
and other things.
Jimmy, put
Okay,
pause-
so
put on pause.
combination square. What is it good for? For measuring things and making things square. All right. So if I want to measure 4 inches and make a line, make a cut 4 inches up from this piece of sheet metal, I'll place the ruler right at 4 inches. Okay. Am I at 4 inches or am I at 3 inches? Joe. Evan, am I at 3 inches or 4 inches?
3. No. Yeah.
It says both. How do you know which side?
Oh, I didn't even see that.
You gotta count. You gotta count from this end here.
Yeah.
Okay. Very good. 4 inches. See how that worked?
Do it again.
No.
Oh.
I will do it again. Everybody watching, you will be able to utilize this technique in a day. All right. So I'm marking my 4 inches here. I just slide the ruler, I slide the straight edge along the edge of this sheet metal. Now I have a square line there. Okay. It's easy. All right. So after you make a line, what do? You cut it, right? We're cutting sheet metal. We're not going to cut that today. So, we have aviation snips, but they are not nibblers, they are shears. A shear is where 2 pieces of cutting blades come together like this, okay? That's shear, so it'll cut as it goes, all right? There is a nibbler, and I'll have to bring it in from my shop, and I'll show you. I got a pneumatic one that's really cool, so we'll have some fun. But that nibbles, and it nibbles into corners, and it nibbles into little places that are hard to get, where you can't use these, okay? So, there are 3 different types, well, there's more than that, but the 3 types of aviation snips are, the yellow is center, the green ones are right-handed, they're right, and these are left. That does not mean that this right one cuts in a right circle. No. doesn't mean that. It means that the material comes off on the right side. Okay?
Okay.
Why would we need these?
You need these to cut the aluminum.
Oh, like why would we need right-handed, left-handed?
Well, you see how the material comes off on the right side? See that?
Yes.
All right. So what if I'm going to keep cutting here. What if I want to cut down this side? I go to the left. Very good.
What if you did it the reverse? What would happen?
If you do it in the reverse, what will happen? What's happening to this piece here?
It's gonna fly off.
The piece
It's what?
of wall is gonna bend.
It's folding up, it's curling, it's bending, right?
You're not gonna get it.
Yes. So if you do it, if you use the wrong tool, you will bend the wrong part. Okay?
What if you use the middle one?
If you use the middle one, that's for like if you have a big sheet and you're cutting down the middle, and it'll kind of bend both sides equally, but not that much. I personally haven't used those in a very, very long time. I went and bought Beverly Shear snips here. They still have left and right, but you'll see it cuts differently than the other ones.
Yes, that looks weird.
But it's so nice
Is it?
because I will use the left hand ones on the right hand side. Doesn't really matter. It did not bend my piece, did it?
No, you did.
No. So, if you get a sheet metal job, spend the big bucks, get the good stuff, okay? But because we have so many pairs of these here, you get to use these style, okay? All right. Once we have cut a piece, sorry about the microphone here. Okay. We have to, these cutting edges aren't smooth, they're kind of serrated. You know what that means?
Sharp.
No, it means they have little divots in them.
They got teeth.
So they're meant for
Little
shredding.
teeth, right? Little scallops.
Butterfly knife. That'd be cool.
Just click.
This is what I'm talking about here, right? This side of the blade. That's what it looks like, but very, very fine. Okay? The super tool has almost everything.
They got teeth.
All right. So the next thing we do is what? We have to make it smooth, right? Oh, that one's out here. All right. This is a file. There are different types of files. This is a single cut file. The cut only goes one way. There's a double cut file where it looks like an X mark going up that's where they crisscross. There's fine teeth.
Is there a Dixon one?
What's that?
Isn't there one that's like a Dixon cut or something like that?
Probably. We don't really use it in aviation. There is also one, I'm going to just say the name because that tool's been around a lot longer than you all have been using it the way you use it. But there's a bastard file, which is so this probably has, in 1 inch, it probably has, I want to say 20 teeth. In 1 inch of the other file, there's 2 or 3 teeth. So it will take a lot of metal off very fast. And you don't use it on sheet metal.
You use that one.
You use it on propellers or castings or things like that. Something very large and only on aluminum. It won't work on steel. Okay? Just to let you know, it is out there. I don't think it's on the test, but on the AAA test. But that is a file. It's a very, very, very coarse file. You would never finish something off with that file. Okay? So this one here is a medium cut file. This is a coarse file. See how you can see how the teeth are a lot coarser on this one. This is also a half round file. There are a couple of these toolboxes have file sets, right, Jimmy? So there's flat, there's round, there's quarter round, there is square files. So they come in small, medium, large, extra large. I would say this is a large one, wouldn't you? Yes.
Quite
All right. So when you file, you get aluminum in the teeth here, right? At the end of your job, you take a file card and you clean those out like this. Go along with the teeth. Okay?
Go along with the teeth. Got it.
Along with the teeth. Do not use this on your scalp. You will seriously damage your head. Okay?
Can I try it? So
Are
it's
those
not,
metal?
Yes. It's little stainless steel spikes.
Skip, damn it, you'll destroy.
talk about
I will not be helping you. I will be calling 911. Just saying.
How do you explain that?
Don't be dumb. All right. All right. So I'm gonna file on this piece. This side here is very rough. It has a rough edge when you cut it. So we have to file this edge. We also need to file this edge because it's rough. And then the corners, you want to round the corners off a little bit. Okay.
What degree? What angle? What degree?
For rounding or for
For your corners.
I will show you. It's kind of freehand. So sheet metal work is like artwork. Okay? You have to learn it. Your hands have to figure out how to do it. There is some science to it, but a lot of it is what I call artwork because there's no exacting science to it. It's all how you do it, what you do it. Building an engine is all science. There's no artwork, there's no guesswork. Does it match the measurements or does it not? If it doesn't, it's rejected. Okay? Sheet metal, I have done, sometimes it'll take me 2 or 3 times to get the right form and fit on a piece of sheet metal to where I'm putting it. Okay?
it means that we'll never be able to.
What's that?
Nothing.
You will be able to. You will. So the sheet metal is not that expensive. If you mess up the first time, try it again. Learn from your mistakes. It's an art form. All right. So I'm not expecting you to be able to get all of this stuff right the very first time. Okay. But like tomorrow's assignment will, you'll be graded on how good it is. All right. So I'm going to demonstrate filing now. On a file, you only go one way, okay? All right, you saw I went one way, I picked the blade up, brought it back, and then did it again, right? So that will take a couple more passes, but just for demonstration purposes, it's a little smoother. Same thing with the top. Like that sound, Jimmy? Isn't that cool? That's the Mr. Microphone holding on to the handle. And it's vibrations coming through the handle.
So it doesn't actually sound like that?
All right. All right, and corners. Yeah, that's not working there. Just a light touch. And then you have to go on each side of it to kind of get the burr off, okay?
Got it.
Does that make sense?
Yes.
Okay. The propeller has a profile. You see how it's rounded on this side?
Yes.
Flat on this side?
Let me check.
So I'm going one way with it, trying to keep that profile, all right? So as I'm going, I'm keeping that rounded edge. You can also go this way with it, but generally you're trying to do the whole thing. And every time we do a 100-hour inspection, we dress the propeller a little bit. So this one has a lot of chips, scarring, a lot of problems.